The next question is, for the ideal gas reaction X plus Y giving Z, a mixture with number of moles of X, Y and Z 1, 3 and 2 respectively is at equilibrium at 300 Kelvin and 1 bar. If the pressure is isothermally increased to 2 bar, the number of moles of X in the new equilibrium is closest to. So the number of moles of XYZ given are at equilibrium. So we can first calculate the partial pressure of each gas using the Dalton's law that mole fraction into total pressure is partial pressure. So partial pressure of X would be 1 upon 6 into 1 bar. Partial pressure of Y would be 3 upon 6 into 1, and that of Z would be 2 upon 6 into 1. Now using these partial pressures, I will be able to calculate the Kp value for this reaction. So the Kp value comes out to be 2 by 6 into 1 divided by 1 by 6 into 1 into 3 by 6 into 1. So that comes out to be 4. Now when we increase the pressure, this equilibrium will shift in the forward direction, right? Because when we increase the pressure, system will try to decrease it by going in that direction where number of moles of gas are less, that is the forward direction. So at equilibrium we had 1, 3 and 2 mole. This was the equilibrium time. Now when we increase the pressure, system will go in the forward direction. So at the new equilibrium, there is 1 minus x moles of X and 3 minus x moles of Y and 2 plus x moles of Z. Again Kp doesn't change, so and the total pressure is not 2 bar. So we will find out the partial pressures of all the three gases. So partial pressure of X would be 1 minus x upon total moles, that is 6 minus x into 2. That of Y would be 3 minus x upon 6 minus x into 2, and that of Z would be 2 plus x upon 6 minus x into 2. Now again using this Kp formula, 4 is equal to 2 plus x upon 6 minus x into 2 divided by 1 minus x upon 6 minus x into 2 into 3 minus x 6 minus x into 2. By solving this quadratic, we get two values of x. One value of x comes to be greater than 1, which is not possible, and the other value of x comes to be 0.36. That is acceptable value. So when you put x as 3 they're asking the number of moles of x at the new equilibrium, which is 1 minus x. So this implies number of moles of x would be 1 minus 0.36, that is approximately 0.64. So the closest answer for that question would be option B.